One of my students came to me and asked, Dr. Shofur, what temperature and pressure I should freeze dry a ripe banana. I said, it is not a straight solution and many factors need to be considered. Please watch this video to understand and select the conditions. In this video, I am going to explain the multi-stage freeze drying process considering state diagram of banana and phase diagram of water. First, I am going to explain the state diagram of banana and its phased boundary lines and critical points, and then explain the freeze drying path. I am showing a complete state diagram of banana from our earlier published paper in the Journal of Food Engineering. In the next slide, I am rescaling and keeping only the required part for the analysis of freeze drying process. The state diagram shows freezing curve, glass line, maximal freeze concentration conditions, that is Tm dash, Tg triple dash, and unfreezable water at solids content Xs dash. Please watch my earlier videos on the basic freeze drying, explanation of freeze drying by phase diagram, measurements of glass transition, freezing point, maximal freeze concentration conditions, and construction of a basic state diagram. The links are given in the description box. In order to select the appropriate operating conditions of freeze drying to maintain low drying time and low cost as well as good product quality, the values of the following parameters are important. The ultimate maximal freeze concentration conditions, that is Tm dash minus 34.5 degrees C, Tg triple dash minus 40.8 degrees C. Unfreezable water at solids content Xs dash 0.74 gram per gram sample. This means unfreezable water is 0.26 gram per gram sample. I would like to emphasize two important points which need to be used in analyzing the freeze drying by phase diagram. These are: less damage can occur if the process is below Tg triple dash, that is minus 40.8 degrees C during sublimation period, that is first stage of freeze drying, and below glass line, that is second stage of freeze drying, which is vacuum drying due to the absence of ice in the material. We could observe the freeze drying path on the state diagram. Consider banana at 20 degrees C before freezing, and we are conducting freeze drying at minus 60 degrees C. The final storage temperature is 20 degrees C. The initial and final moisture contents are 0.90 and 0.05 gram per gram sample. First, locate initial point as A and end point of freeze drying and storage at 20 degrees C as B. During freezing, when the sample reaches the initial freezing point, then we are on the freezing curve. During the freezing process, we follow the freezing curve until it reaches to Tm dash, that is minus 34.5 degrees C. Then we reach the end of the freezing process at minus 60 degrees C to start sublimation, that is first stage of freeze drying. We remain at this point until sublimation is completed. When the sublimation is completed, then we reach the vacuum drying stage, that is second period of freeze drying. Then we reach the end point B. The glass transition temperature at 0.05 gram per gram sample is 3 degrees C. The point 0.05 gram per gram sample is the target final moisture. Therefore, freeze dried product is in the rubbery state. If we need to store the sample in the glassy state, then either we need to cool below 3 degrees C or further dry below the glass line. Now I would like to use a water phase diagram to see freeze drying paths. In this phase diagram, we could locate three phases of water, that is liquid, vapor, and ice. The triple point is located at 0.01 degrees C and 610 Pascal. Liquid vapor line, vapor ice line, and liquid ice line are marked as well. Consider freeze drying processing steps. First, we need to freeze the sample to minus 60 degrees C, and second, need to reduce the pressure below 610 Pascal vacuum in order to achieve sublimation. We could reduce the pressure to different levels below 610 Pascal. For example, 10 Pascal, 3 Pascal, or 1 Pascal. If we use pressure to 10 Pascal, then we need to heat the sample to minus 42 degrees C for sublimation. If we use pressure 3 Pascal, then sample needs to be heated to minus 50 degrees C. If we use pressure at 1 Pascal, the sublimation could occur at minus 60 degrees C. That is, no need to heat the sample. Therefore, these are the strategies to reach the sublimation line, that is, initial stage of freeze drying. In the next video, I will explain the multi-stage freeze drying further. I would like to thank you for watching this video until the end, and please subscribe to our channel if you like this video.